All right, Chapter 8, Section 3, and Chapter 9, Section 1, number of solutions for systems of linear equations and solving by substitution. But in this Apprentice video, we're actually going to look at the number of solutions, well, specifically the nature of solutions of a system of linear equations. So what that means is, given a system, what types of answers can you get? And you may wonder, what do you mean, what types? Well, once I graph each of these three systems, you will understand what I mean. Right, for the first system, both equations are already expressed in slope-intercept form, so that's easy. Don't need to do any work. Next, I'm going to isolate y, so I'm going to get 10y equals negative 4x plus 30, and then I'm going to divide both sides by 10. So those cancel. So I get y equals, and this is reducible, negative 4 over 10. That's negative 2 over 5. So you get negative 2x over 5. And the x can go in the middle here if you like. And that gives me plus 3. Okay, so that would be pretty easy to graph. And then the next equation. So to isolate this y term here, I'm going to first subtract 2x from both sides. So I'm going to get 5y equals negative 2x plus 35. And then I'm going to, of course, divide out both sides by 5. And those cancel. So I get y equals, that's not reducible, so I just leave it. Positive 35 over 5, that reduces to positive 7. Okay, so that's that equation, which I can easily graph. And then I've got this equation. Okay, let's do the last system. All right, so notice how the y term is negative right now. So I'm going to express it on the right, hence making it positive. And that means this negative 6 on the right, that has to go. So I'm going to add 6 to both sides. Doing so, I'm going to get the following. I'm going to get 5x plus 6 equals 3y. And then I'll just divide out everything by 3. And I get 5x over 3. And positive 6 over 3 is plus 2 equals y. So that's that one. Let's do the last one in red. This one's actually quite simple. The y term is already isolated. So to isolate y, I just need to divide everything by 9. You could do that in your head, but I will show it. It's a 15. So I'll divide by 9. Okay. And this gives me y equals, and 18 over 9, that is just 2, plus 15 over 9. Those are reducible. Those are both divisible by 3. So dividing both of them by 3 will give me 5x over 3. So that's that equation. All right. So now all of my systems are expressed in slope-intercept form. So let's quickly graph them. Should be a piece of cake. All right, let's quickly graph these. So in blue, the y-intercept was negative 3, and it had a slope of 2. So that goes up like so. There we go. Okay, and the next one had a y-intercept of 4. That's right here. And it has a slope of 1/2. So that goes like this. So below it says number of intersections, okay, meaning how many places do these lines cross? Well, only once, right here. Now it doesn't appear to be right on a grid line, but it doesn't actually ask us for the solution. It just says number of intersections. Well, there's one. Okay, and you should notice that the slopes of these lines, they're different. Okay, so if lines have different slopes, somewhere at some point they have to cross, and because these lines are straight, once they cross, they will never cross again. All right, for the next system, the y-intercept for one of the equations was 3, and the slope was negative 2/5. Right, so that means down 2, right 5, down 2, right 5, or I could go up 2, left 5. Okay, I think that's enough to trace out my line. There we go. Okay. The next equation, that had a y-intercept of 7. That's right here. But it also had the same slope. So we go down 2, right 5, down 2, right 5, or up 2, left 5. Let's get that in here. There we go. So, number of intersections. Well, the slopes are the same. These lines are parallel. Parallel lines do not intersect. Okay? The distance between these lines will remain the same. So, none. Okay? Because the slopes are equal. The y-intercepts, however, this is 3, this is 5, the y-intercepts are different. Okay? So these lines are parallel. Okay? They never meet. They never intersect. All right, for our last system, y-intercept is 2, and the slope is positive 5 over positive 3, so I can go up 5 over 3. I can't do that again because I'm going to run off, but I can also go down 5, left 3. Down 5, left 3. So let's get my line in place. There we go. Something like that. Okay. Now, the other line, you may notice, is exactly the same. Okay, the y-intercept is the same, the slope is the same. So in fact, I'm going to get the exact same line. Okay, they're right on top of each other. So in this case, the slopes are equal, just like the previous one, but the y-intercepts are equal. See, before, the slopes were equal, but the y-intercepts were not, hence we had parallel lines. In this case, both of them are equal. Okay, so we're not going to say these lines are parallel because they do touch. In fact, they touch everywhere. They're the same line. So when this happens, we say that they are coinciding. Coinciding, which is just a fancy word for saying, you know what, the two lines are just exactly the same thing. It's just when we first saw them, one was just a disguised version of the other. All right, what does all this stuff mean? Okay, what it means is, if I have two lines and I graph them and their slopes are different, it must mean that at some point, I don't necessarily know where, but at some point they have to cross. They have to intersect. And when we're trying to solve a system of equations, remember before we were looking for where they actually crossed. Okay? So if you look over here, we had two lines, but they were parallel because their slopes happened to be the same. But the y-intercepts were different. So if I was to ask you how many solutions are to this system, the answer would be none, because there is absolutely no point where either of these lines will touch. What about this scenario? Well, if we want to solve the system, we're asking for at what point do these lines cross? Well, or where do they touch? Well, they touch everywhere. Okay? Any point that is on the red line is also on the blue line. How many points exist on a line? Infinitely many. So here, how many solutions would there be to the system? Just one, because there's only one point where they meet. How many solutions are there to this system? Well, there are none, because the lines are parallel. They will never touch. Okay? When two lines are coinciding, it just means one is right on top of the other. There are infinitely many solutions, okay? Because any point on one line also satisfies the other.